All right. I'm trying to. Hello, class. Good afternoon. Um, this should be a pretty quick lesson for today. Um, I hope you're doing well. So, what we're going to talk about today is what are called switches. Okay. And so, there are two kinds of switches that I'm going to teach you about. One switch is looks like this, and the switch. So this is the switch in the open position. Okay, so this is a switch in the open position, and if the switch is down like that, that's a switch in the closed position. Okay, so when a switch is in the open position, basically no electric current can flow through the switch. So you could almost think about it as having an infinite resistance. Okay. When the switch is closed, it's basically the same thing as a wire. So current can flow through it freely. All right. So you have an open switch and a closed switch. I like to call this the on-off switch. Okay. Because the switch is either on or it's off. Another kind of switch you can have is a switch that has one, basically it can toggle between two options. So it can be like this, and we could call that the A position. Or you could imagine swinging the switch down like that. So basically this little piece right here can swing up or down. And so that would be the B position. So I would call that I just call that the AB switch. Okay. Now a couple of things here. Let me draw just a couple of basic ways that switches can be connected. So if you had something like this, maybe a switch followed by a resistor. So a switch and a resistor in series. If this switch is open, like it is right now, no current can flow through that resistor. Okay, so that resistor is just completely blocked out of the circuit. So this one is going to get no current. Okay, because the switch is open, so no electrons can flow. Now here's something kind of interesting. If you have a resistor that's in parallel with a switch, and here we have a switch that is closed, in this case, this is the very same thing as the situation we had yesterday where I put the wire that short-circuited the resistor. When the switch is closed, this resistor is short-circuited. So in this case as well, the resistor gets no current. Okay? So let's do some examples. And by the way, these are both with on-off switches. So let's go ahead and just do an example of a really basic circuit that you might see involving a switch. Um, this right here is the circuit symbol for a light bulb. Okay, I think I'm back. So I think I'm back. So anyways, this switch is basically going to turn the light bulb on and off. Okay? So there you have it. Let's do a couple of examples. So I'm just going to draw an example here. Let's suppose we have a circuit. It's like this. Okay. So what if I have this circuit right here, and I want to find the current when both switches are open, okay? So when both switches are open, we can basically, because this switch is open, no current can flow through this branch of the circuit anyways, and also no current can flow through this branch of the circuit. So what that means is that this circuit is basically the same as this one. Okay, so you can see that I have removed any branch of the circuit that has an open switch on it. Okay, so in this case, we can see that the total resistance you can see that the total resistance is about 8 ohms. Okay, and so that means that the current that flows would be V over R. It would be 12 over 8. So that would be 1.5 amps. All right. So that's what the circuit looks like when the switches are open. So now let's imagine that we close both of these switches. So we close this one, we close this one. In that case, once we close this switch, then this so once we close the switch, we have to include this part of the circuit. Once we close that switch, we're now short-circuiting the 5 ohm resistor. So we can just ignore it because it's not going to get any current whatsoever. So once both the switches are closed, the circuit now looks like this. Okay. So so what you want to do is when a switch is open, you want to exclude the branches of the circuit that have an open switch on them. When the switches are closed, you want to include that part of the circuit. Okay, so that's what I've done here. I just redraw the circuit when it's open and when it's closed. So here you can see that the total resistance, or 1 over the total resistance, is going to be 1/2 plus 1/3. And that says that our tote is 1.2 ohms. I believe that's right. So that means that the amount of current that flows is going to be volts over resistance. It's going to be 12 over 1.2, which is 10 amps. Okay, so we can see that the amount of current that flows with the switches closed is quite a bit greater than the current that flows when the switches are open. So this is really what I wanted you guys to learn about today. Is I wanted you to learn about how to analyze circuits with switches when the switches are open, when the switches are closed. Okay. I think on Monday I might do another switches circuit with you guys, but I'm going to wait until I get better internet before I try that. Okay. So I'll see you on Monday, I hope, and please do the homework. And I hope you guys have a great weekend.